My son used it.
And this is part of our Shared Resources Lunch and Learn seminar series. This is the last one that we have for our URMC campus people. I have a QR code, just a little piece of paper. If you can scan it and fill out the quick survey to help us plan for next year's series. We might switch gears. We've kind of provided an overview of what each of the shared resources are and the services they provide. And next year, we'd like to make it a little bit more informed based on your input so that we can better serve our research community and cancer members. So any input you have is greatly appreciated. And I'll send it in a link to the follow-up survey that I send out after the Lunch and Learn. So all your feedback is appreciated. And I'll let Anna take it away.
Hi, everyone. Thank you for coming. I'm Anna Brown. I'm a software engineer, and I'm part of the Technology and Innovation Group here at Wilmot. I'm going to start off talk today, and then I'll turn it over to Cameron to demo some tools you can use. So I'll be talking about our team, the Technology and Innovation Group. I'll be talking about our core product, HyperGen, to tell you what it is and how it a lot of our projects use it. And then I'll talk about HyperGen, how it was developed, and then Cameron will demo that later. Our team is led by Eric Snyder and Erica Ramsdale. We have a really awesome team with a variety of backgrounds. Some backgrounds are research, art and design, math, data analytics, cloud architecture. So this variety of skills and backgrounds makes this team really special and fun to be a part of. My personal background is computer science. I studied computer science at Northwestern. I'm from Illinois. Before moving here to Rochester, I lived in Boston. I worked for Wayfair, and I worked for a startup called EverTrue that made software for alumni management for advancement offices. My first project here on this team was HyperGen, which we'll get to. I've also worked on a couple other reporting tools, and I'm currently working on a project to match patients to cancer trials using AI. So our team is focused on healthcare technology, working specifically on ways to bring together and manage data in healthcare systems. Our main goal is to build secure and easy to use systems that allow healthcare data to be accessed and used seamlessly. The core platform HyperGen pulls together data from all sorts of sources. This makes it easier for researchers and healthcare professionals to find, analyze, and use data, whether they're treating patients or conducting research. So HyperGen, it pulls data from over 130 resources and puts it all in one centralized location. And then this allows us to use this centralized data to create a whole bunch of different applications and different tools to use to help your research. A good analogy is to think about how much stuff you have in a junk drawer. I have several drawers that look like this at my house, but imagine if that junk drawer was like the size of a city and you needed to find a pencil sharpener. That's the kind of amount of data we're dealing with. We have over 6 billion rows of data. So a great way, if someone can just give you whatever you're looking for out of this pile of stuff, that's what we want HyperGen to be to you. We want you to be able to easily access what you're looking for out of tons and tons of data. Our team has made a lot of really cool projects. If you go to our website, I think there's over 20 projects listed. I've picked a few to talk about today, but if you want to learn more, I can chat more after, or you can learn more online. The first project is called Martha that I'm going to talk about. It's built by Scott Cunliffe. It brings together real-time data from cancer genetic testing labs and patient medical records. It puts all the results in a single organized view, which doctors can easily access vital information on a patient's unique cancer profile. It includes links to detailed lab reports and resources on gene alterations, so doctors and researchers can better understand the patient's needs. Data Dictionary was built by my coworker Emily. It's a great tool for users to be able to see all of the fields that we have in HyperGen. thousands of fields, over 300 tables. In healthcare, standardizing definitions is a big problem. Something like patient age can have a huge variety of meanings depending on how it's used. So to be able to see all the different data that is accessible and available to researchers and clinicians is extremely valuable. EOS is a very cool tool developed by my coworker Kevin. It's an advanced multi-dimensional graph, kind of like if you were in like a multi-dimensional chessboard and you could see the relationships between all sorts of different data sets. You can use it to see like the relationships between fields in a database, the databases, the servers, the applications they use, or gene alterations to diseases, to patients, to doctors. It's a really cool visualization tool. HyperGen AI is also created by my coworker Kevin. A lot of you probably use ChatGPT. I use it all the time. But if you're using anything with sensitive information, you obviously can't send it to ChatGPT. HyperGen AI is on-premise, so if you have something that includes patient data or sensitive information, you could use it here on-premise because all your data remains there. So if you have, it also has a lot of AI tools people might want to use, like text completion or audio transcriptions. Something like that would be available to you because it's on-premise. Cohort Builder was built by my coworker Lisa and designed by JC. It's a tool to get instant access to aggregate patient data. So if you are going to start a trial or put in a grant and you need numbers for or information on patients in our area, you can easily filter down, like, let's say I want to see how many females are in our area, get a number, filter down by lung cancer, get a new number, filter down by zip code, get an additional number. So you can really get a good idea for how many people might be in a set that you want to study. And then if you want that group of people, you can put in a request to get all that patient information. One last project to highlight is called Canvas. It's a geospatial analysis tool. It pulls in data from the New York State Cancer Registry, the US Census Bureau, and some other resources. It puts them all in one place so that you can explore and compare data in the different areas around us. So here, for example, I pulled in New York State demographic information for people over 65, and I'm looking also at New York State risk factors for smoking. So if you're doing a study for people in our area and you want to see different risk factors, how that can change, this is a great tool to use. So HyperGen, which Karen will show you, is an application that I built. I worked on it with my coworkers, Scott Peony and Scott Isaacs. Scott Peony is our project manager, and Scott Isaacs did the architecture for the servers. It is a tool for you to process genomics pipelines without really needing to know how to code. It's really easy to use, so you can upload your data, click some buttons, set some certain settings, and just have it run without having to do anything on the command line or anything that involves coding. This is an example of what you would see when you log in. You can see some of my recent test results. Currently, HyperGen offers DSync2 analysis, OpenCravat, and GATK4. When I started working here, it was a couple of years ago. I pretty much started on this project shortly after I started, and it was released a year ago, last November. So it's been in use for about a year, and it took about a year to develop it, just for some timeline information. So DSync2 was the first application to be released within HyperGen. This is an example of what it would look like once you're finished running through your DSync2 analysis. The front end is built with React. The backend is in Python, and R is what's used to run the DSync2 analysis. Since it's been released, so about last year, there's been over 300 runs of DSync2, not including mine. OpenCravat was added a couple months after DSync2. This was a lot easier to add because it's open source code, so this code is available online. However, to get it to be used in HyperGen, we had to edit a lot of the source code so that you couldn't access it unless you were logged into HyperGen. And when you log in, you'd only see your results. So that took a little bit of custom coding to get it to work in our environment, but now everything's on premise, so it's a great way to try out that. GATQ4 was the most recent addition. This was added this past summer, so about a year and a half from the start of the HyperGen project. Again, the front end is in React and the back end is Python. A Conda server is running that does the GATQ4 analysis. This was definitely the hardest one for me to add to HyperGen because the GATQ4 process is so complicated and it takes so long to run that if anything went wrong, 10 hours in, it'd be start back over. But we are running this on HAI. It's one of our high performance compute servers. This app, HyperGen, and the Hyperion AI projects all run on this server. In the future, we're hoping to get faster servers that would even allow us to decrease run times. And right now, the GATQ4 processes run one at a time. We seek to run about 2 at a time, but they're all queued up. So if you queued up 3, we would run 2 and then keep going through the queue. Whereas with GATQ4, it would run 1 and then start whatever is next in the queue. Those are the main things that I wanted to show you today. If the things in HyperGen are something that is useful for your projects, I encourage you to use them. I love to see when people are using it, and if you have any feedback, always feel free to reach out to me. Yeah.
It's not very good.
Oh no. I'm gonna see if we can turn it.
I have a question. Do you have plans to continue to add different types of analysis on here, and like is there a roadmap for PIs?
I don't think we have a current roadmap for it, but that's something that we can discuss.
Yeah, you know, when you give PI stuff, they want more always, so I just like to give them updates if they're coming or if we know of any. Is it based on like demand?
And resources.
And
Yeah.
resources, okay.
How do we access these tools?
There is a link. I can give it to you afterwards, or I can put it up on the screen. If you have access to HyperGen, if you don't have access, you can request access and get access to it. If you have a university ID, though, you should be able to log in. It's been used in classes, so if you have a university ID.
All right, I'm Cameron Baker. I'm one of the senior informaticians within the Genomics Research Center. I'm going to try to talk maybe a little bit more loudly because I heard there were some potential mic issues, but I'm going to be demonstrating HyperGen bulk RNA sequencing. I'm going to be demonstrating a single cell tool that we're in active development with and hopefully deploying soon. I'm also going to be talking a little bit about our new delivery process and reasons for it and how to access it and hopefully ease of use. So we're going to start off by going into this browser here. So this is just what HyperGen looks like at a glance. You can pull up a tab with all of your results. You can see I do a lot of testing here, a lot of development with the Technology Innovation Group. And we can go here and pull up our applications. I'm being working on bulk RNA-seq today using the DSeq2 module. So what we do here is if you receive an RNA sequencing delivery from us, you will get a raw counts file corresponding to the gene counts in your samples. I have a test file here. It may take a couple seconds to upload. I was running this through a little bit earlier, but yes, it has uploaded. You can see right here are the gene names, and going across here is the column names or the sample names and the corresponding gene counts. Kind of like a just check before you proceed within the tool.
Is this something we give in our standard delivery?
We provide the counts file as part of our standard delivery. We also provide a HyperGen link if you're receiving a bulk RNA sequencing project. Now, we have the option to upload group assignments because the tool is capable of performing many, many different comparisons across many, many different samples. But for most of our users, doing manual group selection works pretty well. So for instance, we see all the groups here. I'm going to create an NHG13 group. Just call it NHG13. I'm creating a wild type group called wild type. Called wild type. There we go. And then I'm going to proceed with the selection. So I'm going to call this lunch and learn test. I hope the ampersand doesn't cause any issues. It's going to be a mouse project because we perform pathway enrichments. We need to know whether or not it's a mouse project, a human project, or non-model organism project, or I guess non-mouse or human project. And then we proceed by pressing the run button. We can also switch the order of the comparisons as well, but it being almost a cooking show, I've already run this just to expedite demonstration. So if you open up the resulting HTML file, you're going to see our standard delivery report. And while this may not seem very novel to us, the fact is that you will be running it for yourself. So this cuts down on back and forth communication between you and the GRC, whether you want some samples removed from analysis, or you want to run different comparison groups, or you have counts files that you generate on your own. This reduces the barrier of entry for running the RNA sequencing workflow as we would run it for you. And as you can see, everything is here. All right, I'm sorry, is there a way to pull this down? Yeah, let's pull this down here. Something else that I want to demonstrate is SC Explorer. What you are seeing now is a service provided by Office of Research IT. They provide an RStudio setup that you can just log into. And what we've been doing with them is testing out this SC Explorer tool. This is a single cell RNA, visualization tool developed by some of our colleagues and collaborators within Colorado. And its goal is to reduce the barrier of entry for looking at some RNA sequencing runs, or single cell RNA sequencing runs. As you may know, single cell RNA is messy compared to bulk RNA, and there's a lot more to explore. And also, if you've been working with the GRC, you know it takes a lot of back and forth to get what you want out of these data sets. So this is one of the tools that we're trialing there. It took a little bit to launch up, but in similar fashion, I've also loaded up in another window. This is a view of the data set. I've preloaded some plots here as well. This is a publicly available data set. I'm sorry, I don't have the description in front of me. But using the metadata that we've loaded in, we can easily just visualize some features of that metadata. I've also pulled up a feature plot. This is looking at SLC6A6, a taurine transporter, which is specific interest to our examining this data set. We can also load up violin plots. This is looking at I forget the exact conditions, but this is looking at conditions split by cell type, and expression of SLC6A6 within those conditions. We have more plots that we could potentially load up as well, and we have full control over these plots. We can apply specific subsets to this data set, and other things like that. But if you've worked with us previously, we know we've worked previously within ShinyCell. This tool provides a lot more fine level of control over your data. As you can see, we can also easily generate proportion plots as well. Another major gain that this tool has over our previous tests is it's able to perform differential expressions. So again, I've already run this for us, looking at differences between LNGFR and none. We can perform differential expression using the tool, which, if you've worked with us previously, you know this is a tough barrier to overcome, at least with Shiny-based tools. Let's see if... And then, yes, you can directly highlight your gene of interest. You can pull up gene cards to look at all the... Yeah, you can pull up gene cards to pull up more information about your gene as well. So it greatly expands your availability or your capabilities to perform some of this exploratory data analysis yourself, and to come back with us with questions about how you want us to further approach or manipulate the data set. The third thing that I want to demonstrate is our recent changes to delivery via SMQ-NAS. This has come about for a couple reasons. One, if you've received a delivery link from us previously, you know that those expire around 7 days. So if you don't pull it down your data quick, and it is a large amount of data to pull down quick, depending on your projects, you know it will expire. You know you'll have to reach back out to us, and we'll have to repeat the process again. So what we've moved to doing is delivering it via an internal view of our system hosted by Office of Research IT. And what this does is, rather than just hoping that you get the delivery data in time, hoping that we send it to the right person and not just a random person that has your data, because those links are not secure, and not having to worry about running out of space on your local hard drive, we just push it to this shared university drive. Only your lab has access to it, initially granted to principal investigators, further requesting access for their lab members, and you can just log in and have that data anytime you want. This is the user guide that we provide with each of our deliveries now if they're delivered internally. And here is the basic how to log in. So because this is a Windows system, we provide instructions here, but it's //smdnas2 .urmc-sh.rochester.edu, and this will hold up the shared window view. Now you should only have access to folders that you should be able to log in. So for instance, Eric Small, I see him sitting here, he should be able to only access the small_e folder. Let's see if I can find it. Now I can't access it from here because I believe it's the way that this computer is either configured or the account that's logged in here, but he should be able to access this from anywhere that he has access on the university network. And then he can log in, have his data anywhere. He doesn't need to fill up a hard drive. And then, I'm not saying you would, but potentially lose a hard drive, which we know happens a lot as well, or have hard drive failures. Much more secure, in our opinion, easier to manage. And yeah. So those are the three things that I want to demonstrate. Bulk RNA sequencing analysis via the HyperGen tool, HyperGen platform. One of the things we've been messing around with, which is the SC Explorer tool for presentation of single-cell RNA data, and delivery via the SMDNAS2 server, which is kind of our new paradigm. And that's just some of the ways that we're hoping to reduce the barrier of entry for investigators and analysts and graduate students and others to manipulate and interpret their data. All right.
Two quick slides. One is to thank our community sponsor / champion. So Vivian Palladoro supports the Shared Resources Lunch and Learn seminar series. This year we were able to put on, I think it's 10 different seminars, again, providing an overview of all of our shared resources. We had 201 different people register. I wasn't tracking attendance, but I don't know exactly what that falls down to. And then we have the QR codes at the front that would really help us plan next year's series. So we value your opinion and would like to hear it. And then we can open it for questions now. But yeah, thank you. Thank you, Anna and Cameron. Yeah, go ahead.
Does HyperGen accommodate more complex design matrices, like I want to do cell type plus condition, not just, one-to-one comparisons, but more complex comparisons?
At this time, no. It's a potential for the future, but it's mainly designed to perform just simple differential expression across conditions.
And you
for the
can
time
do
being.
more than two, right?
You can do more than two, or you can only do pairwise comparisons, not an ANOVA-like analysis, not yet.
So HyperGen, is there any suggestion if you have two groups, how to give a label for each sample? So you should just give group one or something like simple ID for each sample.
I can pull up the report.
Like you have Y type and you have those three samples, that's kind of simple.
Yeah.
Human one. And you have ID, and then you want to kind of distinguish between before and after treatments, something like that.
Yeah, we Even though the samples are grouped for differential expression, they maintain their labels throughout, if that helps us.
Yeah, and then assign to, so if you have a couple hundred sample, you have to kind of assign 100 for group A and 100 for group B.
Yeah,
You have to manually select one by one. Or
nope. I'm going to step through this process just a tiny bit because we do allow you to upload.
separate.
Yeah. So here we have upload group assignments. And let me see. So here you can provide a comma separated value file in which the first column would be your samples and then your second column would be the groups that they belong to. So if you already have that on hand elsewhere, you don't have to manually select every single group if you have a large number of samples. Yes.
For the single cell data, one of the questions is always, what is my cluster? What cells are those? Is the SC, I forget the name of the tool, the single cell tool, does it use like other tools that can annotate your clusters or?
This tool is typically downstream of our initial engagement. So for instance, if you're working with us on single cell RNA, we'll do an initial pass of the data and maybe provide cell typing. But if you just take your data and want to run with it, it is possible to look at markers for a data set. Now, I'm not sure how long this will take, but what I'm doing here is I'm looking at marker identification. This is the clustering resolution, and I'm going to run this. And it's only going to look at positive markers. So from here, you could say, all right, I have these marker lists corresponding to the clusters, and then I can apply those labels down the line, or go back to where you generate the data set and apply the labels and then bring them back into the tool. This might take a little bit, but.
And is this tool available or this is just beta where it's?
I would say it's late beta for right now. If you reach out to us and you have a data set of interest, we can look at potentially setting you up. But it may take a little bit to run, which is why I had everything on hand before. Oh. It'll still take a second to update, but. Yeah, so what you see here is the cluster's specific features. It's already been filtered for adjusted p-value. It's telling you some breakdown cells per group.
Then you have to go and look at those markers and figure out what cell.
Yes. Yes.
Can you integrate other existing single-cell RNA sequencing data that has already established cell identities with your own here to sort of streamline that process or help you with this process?
Yeah, what this data set was using, it was already using an annotated data set. So, or in terms of multiple data sets together. Yeah, it doesn't have the possibilities for integrating multiple data sets together within the context of saying like, hey, let's compare this data set to this one and see what our markers are from here. It does have the capability of hosting, I mean, it's not directly applicable to your question, but the tool does have the ability to host data sets in which you have multiple different types of assays, for instance, antibody tagging and RNA, or I believe ATAC, single cell ATAC integrated there as well. But so it doesn't have direct, I want to say, data set learning like you're potentially asking about, but it does have expanded capability over just a demonstration tool that we have been working with previously. Any other questions? All right, thank you.
So,